Okay, section 10.1 on circle geometry. The first section of chapter 10 deals with inscribed angles and central angles. And question 1 says, in the diagram, angle BDA, meaning starting at B, going to D, and going to A. So that angle right there is half of angle BCA. Why? Because it's an inscribed angle to a central angle. But it then says, does the inscribed angle here, with the question mark, be EA? Should that be inscribed as well? Because B and A are connected to, are the endpoints? And the answer is no. Because, does anyone have a reason for that? What is the reason for it? In order for an inscribed angle to exist, it has to exist outside of what we call this area here. What's that area called? Vocabulary, it's called the arc. So in order for it to be inscribed, that has to exist on this side of the arc. Question 3, what are the measures of angle ADB? So ADB. ADB, of course, A and B are connected to the middle as well, making angle C or ACB a central angle, and ADB would be inscribed and therefore is 41 degrees, half the measure of the central angle. Question 4, what's the measure of FJG? FJG, again, inscribed. These 2 points are connected to any point outside the arc, and if those 2 points are connected to the middle, this is your central angle. If these 2 points are connected to H, that's an inscribed angle. So these 2 are inscribed to the same endpoints, making it 23 degrees. And therefore this one, the central angle, would be 46 degrees. Oh, we didn't have to do it? Oh, okay, my bad. Question 6, it says point C is the center of the circle and AD is the diameter. So this line here is a straight line with 2 endpoints, making it a whole bunch of different things. It's a chord, it's a diameter, and it's also a straight line, which is 180 degrees, which means it's also a central angle of 180 degrees. If that central angle, which these 2 points are connected to, is connected to any other point on the circle, it will make an inscribed angle, which D is, and therefore D is half of the central, which makes it 90 degrees. Once we have that, we can take our triangle and redraw it over here. Just kind of recalibrate it over here. 15 would be here, 17 would be here. And the question is asking us, what is the measure of AB, or this distance right here? We'll put X there. In order to solve that, we need to use Pythagoras. And remember, Pythagoras said the legs, meaning the 2 sides that make up the 90-degree angle, the area of those 2 squares attached to those legs add up to be the area of the other. So A squared plus B squared equals C squared. Our A and B are always our legs, so X squared plus 15 squared equals 17 squared. X squared plus 225 equals 289. X squared equals 64. And if I square root both sides, I get X equals 8. Now we get into some fun stuff. It says the circle has a center of C and a radius of 8. FGEG is 45 degrees. What's the measure of FCG, or the central angle? Since F and G are connected to E and F and G are connected to the center, that makes it a central angle of 90 degrees. Since FC is a radius, so too is CG. CG is also a radius, which means the length of CG is 8 centimeters as well. And since it's a right triangle, if I redrew this right triangle over here, I'd have 8 and 8. The question says, what's the measure of chord FG, which in this case would be the hypotenuse of our right triangle. Remember again, leg, or AB, doesn't matter, are the 2 sides that make up the right triangle. So A squared plus B squared equals C squared, or 64 plus 64 equals X squared, or 128 equals X squared. Since 128 is not a perfect square, if we used brains, we would be able to then figure out that 128 square root of 128, 121 is 11, so 128 is about 11.3. So the length of FG. Question 10, beautiful question. Love this question so much. It says in diagram C, in the diagram, C is the center of the circle. Yeah. Angle ABD is 38 degrees, which we now know means that this angle is how much? Anybody? That red angle will be twice as much, correct? Which will make it 76 degrees. So I'll put 76 in there. What is the measure of ACD? That's 76, twice the inscribed angle. What type of triangle is ACD? Anyone want to guess what type of triangle it is? It's isosceles, which means two sides are of equal measure. How do you know that? Well, you know that because this is a radius and this is a radius, and we do not know if AD is the same length, so we only know those two green lines are equal, which makes it, if I draw it over here, an isosceles triangle. What we do know about isosceles triangles is kind of interesting. We know that the base angles, or these x ones, the base angles of an isosceles triangle will always be of equal measure. And we also know that all three angles inside a triangle add up to be 180. So x plus 76 equals 180, or a better way to say it is 2x's plus 76 equals 180. Or those two base angles will equal 104, which means how big is each of those base angles? That's right, 54 degrees. So the answer to that question is how big is the angle? Angle CAD is 54 degrees. Question 11 says point C is the center of the circle, and angle CFE is 25 degrees. Well, here we have a different one, but it's kind of like the last question we just did. What is the measure of angle ECF? ECF, or the central angle. Well, interestingly enough, we don't have inscribed or central angles here. We're not really using that, but we are using this black triangle right here. What kind of triangle is that? Same as we just had before, two radiuses. So I know that this is a radius and this is a radius, right? These two sides are radiuses, which means I have an isosceles triangle. We know that this is 25. Do we know any other measures then if that's 25? We know the other one's 25, right? Because the base angles of an isosceles triangle are equal. Those two add up to be 1/5 or a 50. So what does the other one have to be if all three angles equal 180? It has to be 130 degrees. So therefore, the central angle is 130 degrees. You with me so far? Okay. Now, if E and F are connected to the middle to make a central angle, and E and F are connected to G to make an inscribed angle, what is this measure here if it's inscribed to the 130 degree angle? It is 65 degrees, or half of the central angle. And that's how you solve question 11. You see how that works? Are we good with that? A little bit of logic. I'll go backwards in time just real quick, just to do it with you. So the first thing we did is we realized that the triangle in question was a isosceles triangle with a base angle of 25. Since it was 25, we knew the other angle was also 25 because base angles are equal, and we knew the top angle would be 130, which makes it the central angle of 130. Once we knew that, the inscribed angle to E and F is angle G, which would be inscribed to 130, making it 65 degrees. Question 12, if KJM is 15 degrees, there it is there, right there. And JML over here is 24 degrees. And point C is the center of the circle. What is the measure of each of the following angles? What is the measure of KLM? Well, if we know that K and M are not connected to the middle, if they were connected to the middle, it would be 30-degree angle, wouldn't it? Do you know how we know that? Because the inscribed K and M over here is 15. And K and M are also connected to point L, this one here, which would mean it would be the same measure. It would be the same measure as KJM, which means it's 15 degrees. Okay? So we could put 15 degrees here, couldn't we? All right? B says, what is JKL? JKL. Well, J and K are connected to this point over here, right? M, which makes it 24, and J and K are also connected, or over here, which means this angle is also 24 degrees because they're inscribed to the same two endpoints, which are J and L. So now that we have those written down, it then says what is the measure of, oh sorry, I got that backwards, it's supposed to be up here. JCL, JCL. So JCL, which is not drawn, but if we did it, we know that that's going to be a central angle to the 24, which makes it 48 degrees. And what is the measure of KCM, which is the central angle to the inscribed angle over here, which would make it 30 degrees, right? 30 degrees. It's all about just seeing what the inscribed angles are. And real quick, I'm going to ask you another question. If I asked you, if I put this point here and called it point X, and then asked you, what is the measure of angle LXM? I want you to stop for a second and try and figure that out. Go ahead and do that now. So if I redrew this triangle over here, oh, shoot, it would look like this, 15, 24, and X. Since the three angles inside a triangle have to add up to be 180, it has to be 141, because 15 plus 24 plus X is 180. Okay, that's an aside. Question 13, what is the measure of angle ABE? ABE, this one right here. What is the measure of this? Since A and E are connected to D and A and E are connected to B, they're the same degrees, which means this is 56 degrees. Now, if I draw a triangle ABG, ABG, and I put 34 and 56, do you know how to get AGB? Gavin, how would you get AGB? Add them up and you get 90. So 34 plus 56, the two we know, plus the other one we don't know is 180. Or 90 plus X is 180. How many degrees is that one there? It is 90 degrees, right? X is 90 degrees. Or instead of writing 90, I could get real clever and just do this. Right? And if that's 90, then the one across from it is also 90 because we talked about yesterday, if you have two lines that intersect, and this was 100, a straight line's 180, which would make this 80. It would be this would be 100, and this would be 80. So angles that are across from each other will always be equal in measure, and therefore that will also be 90. Question 14, after looking at the diagram of the circle, Amanda decides to use Pythagorean relationship to calculate the length of chord AB. Will this method work? Let's see. What is the measure of that central angle right there where the black dot is? Dawson, how many degrees is that black dot angle? No clue. Chloe, how many do you think? That's right, 110 degrees, because A and B are connected to D, making it inscribed at 55. And A and B are also connected to the middle, making it central and double 55, 110. You with me so far? So is it possible that this triangle right here, which is 110 degrees, is it possible for her to use Pythagorean theorem to calculate the length of the chord here? No, because it's not a right triangle. So the answer is no, exclamation point, because it's not a 90-degree angle. And our last question says, find the unknown measures of the angles here. All right, let me just make this a little bit bigger. See how well we can do here. Okay, so I'm going to give my diagram a few little numbers here. I'm going to give it, or letters. A, I'm going to put a B here. I'm going to put a C here. I'm going to put a D here, just like that. Okay, are A and B connected to D? Yes. So if I look here with my highlighter, do you see that as being an inscribed angle with a measure of X? Agreed? How do we measure X? How can we figure out how many degrees X is? Well, if I take my black marker and make this a straight line, and make this right here, we know that a straight line has how many degrees? 180. And since this angle and this angle are supplementary to each other, we know that X has to finish the 180 degrees, right? Which makes it 45 degrees. Because 135 plus 45 is 180 degrees, or a straight line. So x is 45 degrees. A and B are connected to that 45 degree angle. So A to B to the x is 45 degrees. And A and B to y would also be inscribed to the same value, making y also 45 degrees because it's inscribed. Question B. What kind of triangle is that? It is a equilateral triangle, not isosceles. Equilateral. All three sides are equal. And yesterday, in our notes, we said if a triangle is equilateral, almost said isosceles again, what are the measure of each angle? 60 degrees. Which means, this is true, and means that x is 60 degrees. Now, if I go ahead and put an A and a B here, is A and B connected to C? So that ACB is an inscribed angle, correct? That X is inscribed. And the I should call this D, I guess. ACB, this Y angle, is actually the central angle to that 60, which means that Y is 120 degrees. How exciting, Mr. Mack? Yes, it is exciting. I could feel the tension in the room. Question C. Ooh, this gets a little complicated. Let's make some letters here. I'm going to put an A and a B here. Does A and B, and I'll put a D and a E here. Does anyone see a known inscribed angle there? Do we see any inscribed angles that we could label and say this is inscribed and this is the measure? That's right. We could say A to D to B is an inscribed angle, and it's 15 degrees. Are those A and B connected to the middle? Yes, they are. Yes, they are. Which means this one right here is the central angle, and how many degrees? 30 degrees. You're all brilliant. Y equals 30 degrees. A and B are also connected to this one over here, which makes angle X the same measure as the inscribed angle, or 15 degrees. That's amazing. So amazing. All right, let's try one more. Last question. I'm going to put A and B and D. Is ADB inscribed? Yes. How many degrees is it? 55. We won't worry about the 55 first. If this here is assumed to be a straight line, if we can assume that's a straight line, you with me? A BCD is in a straight line, which is 180 degrees. Do we know any 90-degree inscribed angles anywhere? Yes, we do. That's right. If this is connected to this into the middle, then this and this connected to A makes this a 90-degree angle. Would you agree? Excellent. And then if I take my drawing and put this here and put my X down here, how many degrees is X? Gavin, how many degrees is X? $35, right? 35 degrees. So X would be 35 degrees because of the 180 rule. And B and D are also connected to point, we'll call it Q. And since this is 180, this is inscribed making it 90, and this is where it gets so much fun. You guys are going to love this one. I can feel you're going to love this one. Since this is 90, this is an isosceles triangle. Those are the base angles. How many degrees are each of those base angles if they're the same measure? 45 degrees, which makes Y 45 degrees.